Hi, welcome to our April meeting of the Mid-City Meetup. I'm happy to see that we had a whole bunch of people RSVP, and I'm really excited to introduce our speaker today. So today we've got Jonathan Charvit as our speaker. He's going to be addressing us about his new book, Data-Oriented Programming. It's outcoming from Manning. I think you can purchase it early as maybe you can fill me in on the details, but they have like an early purchase program where it's digital before it goes to print, don't they?
Yeah, exactly. Like an alpha MVP version of the book or alpha version.
Yeah. And is it cheaper that way if you buy it before it goes to print?
It's cheaper and you get a chance to influence the content of the chapters that are not yet written.
Okay. So there you go. So there's some benefits to it then. You can get on the train early and you can be excited about data-oriented programming. And of course, because you're here at this meetup, you'll be able to know how to explain it to all your coworkers too. So that's great. So we're very excited to have him as a speaker, and I'll just go ahead and read the bio that you gave us, Jonathan. So it says, Jonathan Charvit has been working as a software engineer since 2000, programming with C++, Java, Ruby, JavaScript, Clojure, and ClojureScript. He currently works as a software architect at Scicognito, building software infrastructures for high-scale data pipelines. He shares insights about software at his blog at blog.clips.tech. He writes technical books, he speaks at conferences, and leads Clojure workshops around the world. And he's the author of the new book, Data-Oriented Programming, published by Manning. So take it away, Jonathan.
Yeah. So I'm really happy to be here. Thank you for hosting me, Daniel. It's a real pleasure. Is there a way to know how many people are online right now? So that
let's see. I know that it can show that. Let's see if I can.
because depending on the number of people, I want to adjust the format of the session.
Yes. So what I'm doing is I'm checking on YouTube, but I want to make sure I don't cause an echo, so I'm going to go ahead and mute myself for just a moment while I check YouTube.
Okay, so just I'll give a brief word about me and data-oriented programming and what we are going to do together in the session. So yeah, mainly I discovered Clojure 9 years ago, and since then it has been fun again to be a developer. For the first half of my career, it was not so fun. I always had the feeling that I was limited in my way to express myself. And since I discovered Clojure in 2012, it really has been fun again. And over the last 2 or 3 years, I've asked myself, what is that I like so much in Clojure? Or what is that allows me to be productive and effective when I write Clojure code? I just give you an example of what do I mean by being productive. All kinds of riddles that they ask in a recruiting process, I was really bad at it when I had to solve it in C++, Java, or even JavaScript. And suddenly, after 2 or 3 years of Clojure, I discovered that I was able to solve those riddles very easily because the basic pieces of the language, the collections, allowed me to write complicated algorithms with simple code. So I really asked myself, what is that I like so much in Clojure? And it's not only the fact that it's functional or that it's a list or that we have the REPL, because we have all these things in a way or in another in many different languages. And I also advise with the community, and I came to the understanding that it is data-oriented programming. The fact that Clojure is, I don't know, maybe the only or for sure the first language to embrace data-oriented programming, or even not need to embrace, to invent, in a sense, I would say, data-oriented programming. And the whole language is built around this paradigm that it makes it easy and safe for us, the developer, to manipulate data. And so I decided to write a book. The process started like 1 year or 1.5 years ago. And the publisher was excited by this idea. And the challenge now for me and for the book is to explain the benefits of data-oriented programming in a non-Clojure language. Because for Clojure developers, we have it for free because the language forces us to program according to data-oriented programming. And I believe that we could, if we want to share what we like in Clojure, we have two options. Either convince non-Clojure developers to become Clojure developers. That's one option. And the other option is to go the other way, to tell them about what we love so much in Clojure and why, and then they can adopt part of it in their language. And maybe after some time, they discover that the best way to implement this paradigm is to come to Clojure, but then they come to Clojure after they have tasted the paradigm. And
I'm going to add your screen to the stream so that the
okay.
cover of the book is visible.
Okay, great.
Yes.
So
Sorry.
yeah, so the challenge that I'm facing in the book, and I'd like to share with you, and not only to share, and also maybe to get ideas from you guys, is that, by the way, Daniel, is there a way for people to talk, or they can only view the presentation?
They can only view, actually. So I can add up to 10 people, but everyone that's viewing it is viewing it through YouTube, and there are currently 11 people viewing on YouTube.
I see. So if someone wants to join, is it possible or it's complicated?
It is possible, actually. So I can add them. I can add them by inviting them with a link.
Okay. So please send them a link, and if you guys want to join, it will be very interesting because I'd like this session to be interactive in a sense. But let me finish what I started about the challenge, and the challenge is to the first challenge is to be able to formulate in a non-Clojure way what is data-oriented programming, what are the principles of data-oriented programming. And the second challenge is to convince or to explain or to illustrate what are the benefits of applying each of those principles, and what do you have to trade off, or what do you lose when you apply to each of these principles, because there is no such thing a free meal. It's not that Clojure is the perfect language and data-oriented programming is the perfect paradigm, and when you adhere to it, everything is beautiful. And I've tried different strategies and methodologies, and I'd like to share that with you. And if you are willing to, you can join the effort, and together we can find better ways to explain to our non-Clojure friends what we like so much in Clojure. So let me start by a brief presentation of what is data-oriented programming, and then we'll move to the interactive part. Yeah, so first of all, an important definition is about complexity. The goal of data-oriented programming is to reduce the complexity of the systems that we build. And by complexity, I mean what makes something hard to understand. So the claim is that a system that is written in data-oriented programming is easier to understand. What's going on in the system is easier to understand, and it has nothing to do with performances. So that's the first clarification. And I like to say that data-oriented programming is the secret sauce that makes Clojure systems simpler. Okay. Okay, so basically, here are the three principles that the language agnostic formulation of the principles of data-oriented programming. If you want to say it in one sentence, is that data is a first-class citizen. You could say data is a value also. It's very, very similar. And when you want to make it more concrete, it comes down to three principles. Principle number one is that we separate code from data. So instead of having objects that put together data and code, or data and methods, or data and behavior, or that hides data in objects that or in objects that expose everything through methods, we separate. We have data entities and code entities. And code entities are stateless. And data is data. So, okay, that's principle number one. Principle number two is that the data is represented by generic data structures, not by rigid classes or structs, records, or whatever. For example, in Clojure, we use maps and vectors, and sometimes also sets and lists, but mostly maps and vectors. You probably heard Rick Icky say a couple of times, just use maps. So that's what principle number two is about. The representation of data is through generic data structures. And principle number three is that data is immutable. So just to make things very, very concrete, if you program in a language like Java, let's say regular Java, you break all of the three principles because you have classes that combine data and code together. Data is not usually represented with generic data structures, and usually data is mutable. If you, let's say you write a regular program in JavaScript, you probably you don't violate principle number one and principle number two, because usually data in JavaScript is represented as JSON objects, but you usually break principle number three, because the native data structures in JavaScript are not immutable, they are mutable. If you write code in a traditional functional programming language like OCaml or Haskell, you adhere to principle number one, you adhere to principle number three, because usually in functional programming we don't have side effects, but you don't you violate principle number two, because OCaml and Haskell are statically typed languages, and as so, they force you to define the shape of every piece of data. You cannot have data without having a data type that defines the shape of the data. So principle number two is not is violated in traditional functional programming. And that's an important point, because it might sound that data-oriented programming is the same as functional programming. And the core difference between data-oriented programming and functional programming, or between Clojure and other functional programming languages, is point number two, that we represent data with generic data structures. Okay, so that's the principles. Now comes the question about the benefits of the principle. And I'd like to make our life difficult and address probably the principle that is the most complicated to convince people, the hardest to convince people about those benefits, is the benefits of the principle, and it's principle number two. And why is it the hardest principle? First of all, because it's the one that differentiates, as I said a few minutes ago, between Clojure and other functional programming languages. And secondly, is that because it somehow relates to the war between statically typed and dynamically typed languages. And I'd like to avoid this war. I don't think that war is useful, but I'd like to try to find a way to better illustrate or to better understand the trade-off. What do we gain when we represent data with generic data structures, and what do we lose when we represent data with generic data structures? So if some people want to join, I really invite you. And if no, me and Daniel can talk. And
yeah, two people have joined already, actually.
Oh, I cannot see them.
Yeah, I haven't added them yet, but here they come.
Yeah, okay. So please add them.
Please let me know if you don't want to be on YouTube, because we're planning to
Okay.
recording on YouTube. But I think everybody has had a chance to acknowledge that now. So I'm just going to add Alex. I'm going to add you to the stream. And
Great.
So welcome to the stream, everyone. And here we go. I'll just mute myself again.
Okay, so feel free to open up your mic and so I have two pieces that I'd like us to address together tonight during the session. First one is that I came up with 6 challenges, 6 small code challenges with a solution in data-oriented programming. Here it will be in JavaScript, but it could be exactly the same in Clojure. And the goal of the challenges is to illustrate how easy it is to implement them when you use data-oriented programming, and how difficult, or that it's more difficult to write the code that solves them when you are not adhering to data-oriented programming. So that's one piece, and which is very, very practical and down to earth. And I have the opposite piece, which is very theoretical, which is a definition of 9 concepts from programming, general concepts, like you see here: abstraction, concretion, identity, information, loose coupling, maybe, names, state, and value. And the definition of the concept in the context of data-oriented program, or I should say, the interpretation of those concepts by data-oriented programming. And when you understand those concepts, you are, let's say, half convinced that data-oriented programming is beneficial. So we could start either from here or from there. I let the 2 people that joined decide what is your personal preferences. Would you like to start with the theoretic part or with the practical part? Alex, you decide. Oh, I think you're on mute. No, I cannot hear Alex. You were?
Yeah, when you spoke, we weren't able to hear you, but it doesn't show you as being on mute in this software.
Hi, can you guys hear me?
Yes, we can.
So you get the vote, right? What do you decide?
Well, you don't really have to convince me, obviously, but I like to hear the theoretical part.
Okay. So what I'm going to do is to share the link to this wiki page on GitHub in the chat. I don't know where does it go. If you want to share, Daniel, to the YouTube feed, or if you can read here on my screen.
That's what I'll do. I'll share it to YouTube.
And you can edit it as we go, okay? So I'm going to go through all of them one by one. And when I talk, feel free to edit and to, so even people on YouTube can contribute to the session by editing any of the article. And the order of the article is only alphabetical. It's not order important. And there are, lots of interdependence between the concepts. So there is not really a good place to start and to end. So let's start by what is an abstraction. In object-oriented, they like to say that object is a data abstraction. And Richiki likes to say the opposite, that objects are data concretion. So this is my take about how I understand the concept of abstraction. So abstraction is drawing from a set of exemplars something that is essential. And once you address the essential thing, you get back a better understanding of the exemplars. And we do that a lot in mathematics. All the properties that we know about numbers, we don't know them from the numbers himself. We know them from the algebra in mathematics. So for example, you could look at numbers as a group or as a field, and you analyze the properties, the abstract property of a field or of a group, and then you are able to apply back to the numbers. Because the reality is too messy, it's too difficult for our mind to handle the reality as it is. We need some kind of abstraction where everything is beautiful and organized, and then we can prove theorems and apply them back to the reality. So let's take another example. Relational algebra, SQL, if you want, is a data abstraction. Imagine a world before SQL. And your system is made of users, products, passwords, websites, e-shops, email, subscription, whatever. And you ask question to the system, what are the products, the product that was most purchased by this user? Or what is the average number of purchases in March 2012? And imagine you have to write this code for each and every query. Imagine you don't have the relation abstraction, the table abstraction, or any abstraction. You just have the data itself. It will be very hard to write, or maybe not hard, it will be very painful to write the code that handle all those queries. And you will have to write again and again and again for every kind of entities, even if the question is the same. If you ask yourself what is the most popular book, or the most popular user, and the most popular product, you will write again and again very similar code, but there would be no way for you to reuse the code, because once you deal with books, and then you deal with user, and then you deal with products, and there is nothing apparently in common. And the beauty and the power of relational algebra and SQL is that if you organize your data in tables or in relations, then you are able first to express the query in an abstract language, SQL, number one. And number two, once someone writes an SQL engine, you can use it in every scenario, in every situation with every kind of entities. And that's the beauty of abstraction. So relational algebra is a useful abstraction. It is a data abstraction, and it is useful twice. Once, because it allows you to express the query in a clear way. And secondly, in terms of implementation, you need to implement only once. Okay, so how does it relate to data-oriented programming and to Clojure? So in Clojure, we like to say that we use maps. We just use maps to represent data. And maps have a well-defined algebra. You could merge two maps. You could ask whether a map is a submap of another map. You could rename the keys in a map. You could select some keys from a map. You could subtract some keys from a map. You could, take map over the values of a map, map over the keys in a map, map over the keys and the value in a map. There is, all the functions that we have in the Clojure core library are abstract. In a sense, it's a data algebra, and it's available for us as soon as we agree to represent our data as maps. And I don't know if it's clear. Can you see the connection between what we do in Clojure when we use maps and what SQL and relational algebra gives us? Does it make sense?
Yeah, I like that comparison. I think that's pretty good. If I think about a podcast I've listened to recently, the Functional Design and Clojure podcast, they went to a great deal of effort to talk about core functions individually, and that's kind of one of the main themes of it, is that when you make your data all conform to like the standard generic data types, like you can reuse all these functions. And so it's exciting to hear you link that to SQL, because I feel like maybe that'll be a good way to explain the mindset to someone who's not a a functional programmer or a Clojure programmer.
Yeah, because everyone likes SQL. I don't talk about SQL the syntax, whether it should be strings or not strings, but as a concept is super powerful. And if I take what you said just to add a bit, it's not only that it's convenient to use all those methods and you don't have to write them again and again, it's also allows you to use a language. It's meaningful to say I want to merge those two maps. It's not meaningful to say I want to merge those two classes. So even in terms of expression, it's beneficial. It's two sides of the same thing. Clarity of expression and ease of implementation. So that's one thing that they don't have in OCaml and in Haskell. Because in OCaml and Haskell, every data type has its own product type, you know, integer, cross float, cross string, or whatever. And you cannot manipulate a record freely with an algebra. So that's one thing. Okay, everyone in the talk in YouTube or whatever, if you want to take this wiki page and improve or make it even clearer, or I don't know, someone told me that relational algebra is not clear for everybody. So even if you want to add parentheses, SQL, or add a link to the Wikipedia page about relational algebra, it will be very super useful. So every contribution is welcome. So let's travel the graph of the concept and let's go to concretion. So concretion is the kind of the opposite of abstraction. Concretion is concrete, abstraction is abstract. So what's the formal definition? Concretion is when we, in order to use something, we have to know, we need a concrete knowledge about the thing itself. And not only the interface. So every time in software you use something, you need to know something about the thing that you use. You cannot use something without knowing anything, right? It doesn't make sense. Even if you need to press a button, you need to know where is the button. But when you press the button, you don't care if it's implemented in JavaScript or in Java or in TypeScript or in ClojureScript. Or is there one handler, two handlers, or 10 handlers? There is a button and it works as a button. So the interface between the user and the application is not concrete, is abstract. And again, in classic object-oriented programming, they have this thing called dependency inversion principle, which is it's not a design pattern, but it's a meta pattern if you want. It's a good principle that we should follow. And it says that entities must depend on abstractions, not on concretions. And what they mean is that when a method from class A wants to call a method from class B, it should not call the method from class B directly. There should be an interface, and A should call the method of B through the interface. And then you have the freedom to replace B, right? Even if there is only one implementation of the interface, it makes sense to apply this principle because it allows you to work with abstraction instead of work with concretions. So that's the common way we interpret this principle in object-oriented programming. But if you think about that, when you want to pass data to a method, let's say you want to I don't know, edit a document on Google Docs through the Google Docs API. How does the Java SDK look like? There is an object called, I don't know, Docs, let's say Google Docs. And in order to communicate with the object, you need to build another object, or, sorry, not to build another object. So this object exposes a method, let's say, edit document. But the way you pass the information about the document that you want to edit, the name of the document and the line in the document that you want to edit, is through the object itself. So you have to call many different methods of the object just to pass the information about the modification that you want to do to the document. While in Clojure or in JavaScript, there would be a stateless object, a static function called Google Docs that receives a hash maps that describe the change that you want to apply. And these maps will be made of, let's say, two fields. One is the name of the document, and maybe three fields. Three, the line number that you want to change, and four, the text that you want to insert at this line. So the information that you need as a consumer of the Google Doc API in JavaScript is only about the fields in the map. So it's abstract. The information that you need to know when you use the Java API for Google Docs is more concrete. You need to know the method of the class that represent the document. Set title, set line number, set whatever. And it's not only that you need to remember the name of the function of the method because it's the same. Remembering the name of the method or remembering the name of the field is exactly the same. But it's more that in order to use any method or any object, you need to include all the class definition. While in JavaScript or in Clojure, you have the function and you pass to the function data. So in this sense, it's more abstract. It's not concretion. So I don't know if I'm clear enough. Let me know, guys, if you get the idea.
Yeah, I'm recently becoming more familiar with Java's new patterns for doing a lot of the same types of streaming that would be natural in Clojure. And I can say that when you get concrete about it like that, when everything is very specified and typed and everything, the structure becomes like an entire new hurdle of all of its own, you know. But in Clojure, there's things that they would be just as natural as any other part of the code when you're, you know, mapping and all that stuff. So
yeah, let's say that you have separated. You have the method from the static method of the Google Docs and the data that you need to pass, and the data is represented with a class. So you need to import both the static method definition and the class definition. While if you decide to represent the data as a hash map, and it could be done in Java, there is nothing that prevents Google Docs API to receive a hash map, right? And if they go this way, you need to import only the definition of the function, and you pass it a hash map with the appropriate fields. So that's the theoretical background between, or the power of just use maps. It's really not a concretion. And I have this table here that goes from the most concrete to the most abstract. So the most concrete is when you write your code as a concrete class, and the data as a concrete record, or the two together in a concrete class, doesn't matter. A bit less concrete, and this is what they mean with the DIP principle, is that you have abstract class for the code and abstract class with getters for the data. But still, even if it's abstract, you have to get a concrete knowledge about the interface. And if you go more abstract, you use generic maps for data and message passing for the code. And that's, by the way, from what I understand, passing a message instead of calling a method of an abstract class is the way we do object-oriented programming in Smalltalk. We just send messages as strings, I think, to objects, and they call the code that corresponds to the object. You don't need even to import the interface definition in order to use it. You just send a message, not over the wire, but you just send a message to an entity as a string. So that, and we don't do that in Clojure. So Clojure is very abstract in terms of data representation, but it's not very abstract in terms of code. We don't use message passing in Clojure to call a method of a record or a function. We use the specific instance of the function. So I like this table. It helps to make things very tangible.
Yeah, I think one of, just practically speaking, right, one of the great benefits is that in object-oriented programming, like you said, it feels like I have to, everyone's kind of reinventing the vocabulary of like, how to name the methods and how to structure the objects. And then there's always like, some manager and coordinator and some generic things that you have to give a name that don't really serve a lot of purpose, right? And in Clojure, I can just, rely. And as you said, in modern JavaScript, the same, right? I can kind of rely on these standard, map and reduce and filter and all these functions and apply them to, mostly vectors of maps. And I don't have to relearn that or reinvent that every time I build out an API or a library or have to use it. And I think that's really for me was, just removing that boilerplate of having to like, mentally invent it. And then also as a user, right, to kind of like relearn. And as you said, I think, like complex libraries like Google's SDKs is for me a good example. When I have a wrapper in Clojure, right, it's so simple. After I simplify it and it's so much easier, right? Now I can just say like, hey, give me a vector, give me a collection of documents, right? And then I can do something and do something with those documents, which is a lot simpler than, like you explained, right? Like, oh, I have to think about, oh, this is a document object. Now I have to like somehow figure out what are the getters and setters to get at that piece of data that I'm really interested in, and then do something, right? And then there's so much complexity involved. And then I have to, give names to intermediate results, right? In Clojure, I can just thread things through and then get to the thing that I'm really interested in. And I always, in object-oriented programming, I always feel like, oh, I have to give, things names for intermediate results. And then like, it takes so much time until like, oh, I only was really interested in this string, right? That's all I really wanted is like the name of the document. But you make me go through like so many layers until I really get there. And a good way, I've been using a lot of I'm working a lot with Google Cloud. So like there's, they have the Java libraries, right? The SDK to access all their APIs, but then they also expose just a RESTful JSON API. So I've been just using that directly because it's so much simpler. Yeah. Instead of like having to go through all these layers, right? And like import all these libraries, and then at the end, all I really want, right, is like, oh, I'm just gonna like parse the JSON into a map, right? And then that's what I work with. And then same when I send something right to the API, I just basically have a map and then serialize that into JSON, and it's so much simpler than having to go through all these layers in object-oriented programming that they make you invent it, right? And
What's your name?
Sorry, my name's Simon.
Simon, let me be the devil advocate, okay, for a second.
Go ahead.
What would you answer to someone that says, but then you lose auto-completion because you don't know the name of the fields in the map? While with classes, your IDE can auto-complete, and if it's line number or D line number or uppercase line number, how do you, and with maps, we lose that. So how would you answer this question?
Right. Well, obviously it doesn't prevent you from writing bad code, right? And I think, really thinking about, I do think that's a big challenge for me, is, as I have maps, right, that kind of grow, making sure that, I know, obviously using namespaces and really thinking about what I put in the map, and then, making sure that, I don't get like a null pointer exception like way down the stack just because it returned nil at some point. So I think, it's the same challenge, right? It's really about thinking through your data model. And I think I like your example about SQL, right? Like, well, you don't just go in a relational database, right? And don't think about your data model, right? You sit down and you say like, oh, this is exactly the table I need, and these are the columns, and this is how I'm going to fill it up, right? And you even have to think about indices and all these things, right? So it's you put that work in, and I think that same work, pays off if you do that, obviously in Clojure, and it's more like a document store, obviously, because a map can have, arbitrary name value pairs, which you don't have to predefine. And I do think, right,
to me, it relates to the different distinction between simple and easy.
Right.
So why? Because for someone, let's say, that has an excellent memory, it's not an issue to remember all the names. But even for someone that is an excellent programmer and has an excellent memory, it's still cumbersome and complex to use the Java SDK API. It doesn't. So in a sense, maps, auto-completion, yes, no, it's a subjective question. For someone, it's important. For someone, it's not important. But having all those layers of objects, for everybody, it's a problem.
Right. Yeah, I agree.
And the tragedy, in a sense, is that we are, as an industry, we are very, very attracted with the easiness, or how fast can I write something without understanding anything. And I had a funny experience yesterday. I discovered a great language called TypeScript, and it's really awesome. I just heard about it, but because someone sent me code snippets in TypeScript that solved the book, and he's trying to convince me that it's much better than JavaScript and Lodash. So I gave it a try, and really it's amazing what Microsoft has done with TypeScript. It's amazing because they give you typing a la carte.
Right.
And it's very similar to what we do in Clojure with Spec or with Mali or whatever. That you have a way to type your schema, but you are not forced to do that. And in TypeScript, they do the same. Where you want, you can plug types information, and when you don't want, you don't put type information. And so that's just an introduction. And I try to play with the TypeScript compiler itself to be able to evaluate TypeScript code in the browser. And indeed, the IDE gave me type completion, but I had no idea about the meaning of the fields. So there is allow strict or strict allow or strict. And in order to know what it means, I had to read the documentation. So the auto-completion didn't really help me in a sense. And as you said, when you want to retrieve data from an SQL table, you have to know the schema of the table. You cannot guess. And that's life in a sense. So in a sense, we are decoupling our code from the data, and we lose a bit. We create more of a distance between the code and the data, and it's beneficial in terms of modularization, loose coupling, etc. And in terms of easiness, we lose something, and I think it's important when we talk with non-Clojure developers to acknowledge what we lose, and not to pretend that we are in the best world and we don't lose anything. We lose that when we use dynamic languages. We use the easiness. Okay.
Right. Yeah, and I think right, pointing out that hey, the tooling is different, right? Like instead of relying on auto completion, right? That's where the REPL comes in, and you sample the data, and then you can just kind of like inspect the data as it is, right? And then kind of like obviously what's most attractive. I used to write mostly Java, and what's most attractive is really like being able to explore and building it up in an iterative fashion, right? As opposed to like writing tests, compiling, check if this works, right? And then I push it to production, and then it doesn't work because I missed some corner case, right?
Yeah.
And then it's like, okay, I have to go back,
also,
right?
I played also recently with the Java shell, and it's not bad at all. It's really an amazing tool that they made.
Absolutely, yeah. And I think I think Rich said that too, right? If in large Java shops, right, you obviously you could write Java in a very similar fashion, right? You can have a lot of like just static classes and methods that operate on immutable maps, right? It's just not very ergonomic. It just doesn't feel natural to do it, but you absolutely can write obviously Java in that way, which is very similar to Clojure. It just doesn't feel very natural, right? And then like threading things through and whatnot, you still end up, But I do think modern Java is, is definitely closing the gap, right? is absolutely with the stream abstraction and whatnot is very similar. It's just, again, it just feels bolted on, right? Whereas in Clojure, it like, really is integrated into the language and is very consistent.
Yeah.
And that's,
let me show you what I did in Java to illustrate how we could have kind of just use maps in Java. And when I did that, people on Java Reddit, they wanted to kill me. It's crazy. They want to how do you say, they removed all my posts in Java.
Oh, they did?
Yeah. And they say I'm intolerant and I cannot accept feedback and critiques. Someone said you are a lazy person, and I respond, why are you violent? And then the moderator say, when someone disagree with you, you treat it of being violent instead of accepting his critics.
All right.
It's very interesting. So, very interesting.
Very defensive, huh?
So let me show you what someone told me to do.
Is this all part of your book? I've been following a little bit. I haven't been able to read all your blog posts, but is this part of the book you're working on?
So far, now the book is the illustration of the idea in the book are mostly in JavaScript. Depending on what we think about the Java market, I would add an appendix at the end with all the code snippet translated to Java. But okay, if I see that the Java community is not interested, I'm not going to do the effort.
Yeah. No.
So we could do something like that. We could do, let me remember. Yeah. So let's say we have a catalog. Catalog is a regular Java object. Let me show you the definition of a catalog. So here, this is a catalog. By the way, are you guys familiar with Java records?
Yes.
It's something in Java 14.
Yes, I read about it. Yeah.
Yeah. So it's probably not yet in production in many shops, but it's in Java 14. And it's an immutable record. It's an immutable class made only of data. And first of all, it's very ergonomic to define a record. So, for example, a catalog is made of an item, which is a string, books by SBN, which is a map of the string maps of books, and author by this is the string maps of authors. And here I instantiate the catalog, right? And it's at the end of the day, it's something like that. Here is how a catalog looks like in JSON. So it's a nested map, let's say, but I'm able to represent this nested map as a regular Java record or class. And the natural way to traverse the map in Java is with the dot notation. So you start from a record and then dot books by SBN, etc., etc. But there is a way to define, and in Clojure you would use getIn and pass the path that you want to access, right?
Yep.
So what's interesting, there is a way to do that in Java. So that's the regular way in Java to traverse the path. And you have to go through all those methods. And here is the concretion. You cannot traverse the graph just by knowing the names of the fields down the path. But actually, there is a way to do that. Let me show you. There is a way, and this is Java. So you could have the information path as a list of strings and use a static method called getIn as string and pass to the method the record and the information path. And any idea how this magic is possible? How is it possible to have a list of strings and to traverse a tree of classes? It seemed like a contradiction, right?
Right. Yeah, I saw it using reflection. Yeah.
Yes, exactly. And it's not so hard. So that's the code for using reflection. There is a get somewhere. Yeah, here is the code for accessing an arbitrary field in a Java record. So, and so that's one approach. And another approach, which is more interesting, I think, and more Java-like, is to define a getter, but not inside the record, outside the record. Something like that. So you could create a generic getter, and this is the field name of the field that you want to fetch, and this is the type that you want to fetch. So you create a generic getter that you call title, and then with title in your hand, you are able to access the title property of Watchman. And Watchman is a record that has a field named title.
Cool. Yeah, totally.
And that gives you kind of data-oriented programming in Java.
Yeah, and I think they don't like it because obviously if you do reflection or any of those things, right, you the compiler doesn't know what to do with it, right? So then you lose compile time safety, which, you know, again, there's obviously some benefit to being able to know, hey, it compiles, right? That you have some guarantees if it compiles, and obviously you kind of lose that. And I think that's, again, it's just not very natural to think that way in Java, in my opinion, right? You can use an immutable map, right? And I'm not sure if you're familiar with the Guava library that Google maintains. Yeah, so they have a lot of those best practices that are reflected in that, right? It's just trying to be, you know, don't use mutable objects and all these things. And again, it's just like it requires a lot of discipline and tooling on the side of the programmers to do it right? And it's very easy to slip. And the same with JavaScript. And I think that's really like, you know, I don't think anyone argues about the benefits. I think it's just like you come from different ways to get to the same point, right? It's like, I mean, if you look at modern JavaScript, right, the whole thing is based on message passing, right? Everything is message passing in JavaScript. And like you said, right, Smalltalk is what from 60s, 70s. It's not. Erlang, that's the same thing, right? It's those principles haven't really changed. It's just like, can you make it performant? Is there the right tooling? And then, do people, you know, think about it that way? And is it compatible with the libraries you're using, right? That for me, the most frustrating part is like, whenever I, you know, have a wrapper in a Clojure wrapper with around a Java or also a lot of the JavaScript libraries, but it's like, well, I'm fighting against it, right? Because again, I have so many layers that are you know, all these objects that I don't care about. But let's try. What else is my point? But yeah, this is really cool. I mean, I like the.
Okay, let's read another one. By the way, let's check if someone made a revision to the article. Oh, 2 revisions. Great. I know.
I made a very small one. I just added the word "the."
Oh, where? 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 Which one?
I added it. Let's see. Scroll a little more.
See the diff. I'm looking at the diff.
I'm not sure there is history here.
Yeah, that's it. In Clojure.
Oh, let me see. 2 revisions. Oh, here we go.
I mostly made it just because I wanted to try it out. But I was listening too intently to really read too much of it and find a good thing to edit.
Compare revision. Okay. So here we go. The Clojure idiom. Great. I'm so happy. So everybody on YouTube, either you're watching now or in a delay, live or not live, you are very welcome to contribute. So let's take another one. Which one?
As I was telling you, I'm pretty excited about this type of learning, the live learning over video call, but with a live collaborative component as well. So I think it's pretty cool that you're doing this, and I hope everybody participates.
Where do we stand in terms of time? Are we limited or unlimited or whatever?
Well, my workday is going to go on, so maybe in about 20 minutes or so, I'd like to get back to my.
Okay.
Because I'm on my lunch break now, so.
Okay, so let's stay together for another quarter of an hour, 15 minutes. Yeah. Which one do you want, Alex or Simon? We did abstraction, concretion.
Could you hear me now?
Yes.
Oh, okay. Just continue on with the rest of these things like identity information and all
Okay,
and so on.
let's take identity. Okay, so what is an identity according to Clojure philosophy? So the definition starts from something very abstract and formal, and hopefully it will get clearer with the example. So identity is a stable logical entity that humans or programs associate with a series of different values over time. Important thing, an identity is not the same as a name, right? So for example, a person, Alex, I might call you Alex, but your brother will call you my brother, and your mother will call you my son, and your neighbor will call you my neighbor. But we all use different names to refer to the same entity, to the same identity. And the values are, so let me show you what are the values with an example. So here we have an identity. In Clojure, we could represent an identity with an atom. At the beginning, the atom contains nothing, the value nil. And we give a name to this identity, John. Okay, put that aside for a moment. And then we have a value, John state, and we call it John state on March 2021. And it's a map made of 3 fields, age 42, first name John, last name Doe. And now comes the interesting part. What we do with the reset function in Clojure, we take an identity, the one that is referred by the name John, and we say that right now, the value of the identity John is this guy, this value. And in another line of code, we could say, no, the value of John is something else. So we have identity is like an aggregation of different values over time. At each point of time, the identity has one value. The important thing is that the value exists even when disconnected from the entity, from the identity, sorry. So when I reset John to another value, nothing happens to this value. This value will stay the same forever. If I want to be a bit poetic, I would say values are eternal. Values cannot change. There is no logic way in the world that I could say this map, now the age is 43. Even in a year, if a year has elapsed, it's not that this map is the age, in this map the age is now 43, is that there is another map where the value of age is 43. So let me describe exactly the more precise as I can what's happened in those lines of code. So John is a name that refers to an identity. The identity is represented as an atom. The map with the fields age, first name, and last name is a value. And after calling the reset form, the state of the identity referred by the name John is the map with the fields blah, 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 blah. Okay? And in object-oriented programming, what we do is that we conflate together. So identity is an object, but object and values are conflated together. We don't have access to all the values in an object outside the context of the object. We could access every one of the fields. I could retrieve the age of the person object, and it will be 42. And 42 will stay 42 forever because it's a primitive value. But in classical object-oriented programming, there is no way for me as a programmer to get access to the aggregation of the fields. The aggregation of the fields exists only in the context of the objects. There is no way to get a snapshot of the state. and to keep it. I could clone the object as a workaround, but it's not, philosophically, it's not the same at all. Okay, let's traverse the graph and go to state.
Just real quick, I think I kind of like, I think for most people talking about equality, might be a good way to kind of illustrate those concepts as well. Just, like if you've ever implemented equal in Java for a Java class, you will know the challenges involved with it. So I think that might be a good way to kind of illustrate the differences as well.
I have an example also in React. In React, to determine whether the state of the application has changed or not, or the store, you have to go through all the leaves and check. Even if the references has remained the same after an iteration, you are not sure that the data is the same because you allow mutation.
Yeah, that's a good example too.
Yeah, and in the book I use that a lot to. Sorry, go ahead.
Oh no, I'm just not happy with the example because you're using atoms and basically changing the value of an atom, right? I don't know. It doesn't feel very Clojure-like to me. I would have thought that the identity is something that is something associated with values over time, right? And that it does not necessarily have to be an atom, but in this example, you could have set that John atom to something else entirely, right? That not.
Yes.
So I don't know. It's just I just think that the example could be better.
Yeah, I totally agree with you, and I would love to find an example in JavaScript. And just before the talk, when I was preparing, I considered to change this example and rewrite it in JavaScript, but then I couldn't find a way to make it, because I need the three levels: the names, the variables, the identity, and the value. And in JavaScript, if I would use a var and write John equals John state on March 2021, it will not convey the fact that we have the three levels. I could use pointers maybe in C++, but so if you have a better idea, yes, I'm not happy with the fact that it's
C++ programmers might be more willing than Java programmers to embrace data-oriented programming.
You think so?
Maybe, from what I've seen.
And by the way, I must show you something I discovered yesterday. It's really a gem that I'm going to share with you. And I think that just for that, what I'm going to share right now, it has been worth to attend this meetup. Look at that. It's a paper from 1981. 1981, 40 years ago. Values and objects in programming languages. And I think this guy, Bruce McLennan, is a genius in the way he explains so clearly what's the difference between values. Instead of identity, he called it objects. What are values? Values are eternals. Values are abstractions. Values cannot be counted. But we need objects in programming. It's really, really, really beautiful. I'm going to share it with you guys. I read it. I could not stop reading it 2 days ago. It was on my couch. I didn't feel well, but I read it, and it's really, really, it's amazing how easy it is to read and how deep it is. Objects can be shared. 1981. Objects can be created and destroyed. Values cannot be created and destroyed. Values cannot be shared.
Was there a conclusion to it, or?
Yes, yes. Most languages confuse values and objects, and that's a big source of complexity and mess. And then he has this thing. I love this sentence. But programmers need objects. We cannot work only with values. We don't do maths in our computer. We do real stuff. We need objects. Names should be fixed. Conclusion. But he has this thing. Let me find it. Just a second.
This is how I know I'm in the right conversations. Whenever someone recommends an old paper, I always know I'm in the right conversation.
Yeah, and if you want to feel even better, let me show you something else. Let me show you the real stuff. That's fake. Here is the real stuff. Sorry. My bad. Here is the real stuff. Here you go. 3, 2, 1. Oh, that's the real stuff. That's the original paper. So I'm going to share this one also with you guys.
And the links that you share, I've been putting into the YouTube comments. So hopefully all the participants there on YouTube will be able to see them. But they'll appear as though I posted them. So I don't want to take credit for the great link.
And let me here, I was able to find the quote that I wanted to share with you. Here is, can you see this one? Programming is object-oriented mathematics. Mathematics is value-oriented programming. I like this.
Yeah, it's a good one.
This guy. Do we have time for another one, or should we wrap up?
For my part, I need to wrap up, and I hate to be the one that shuts the door on the rest of the meeting continuing, but I think if I have to go, I think everyone has to go. So
yeah, okay.
Unfortunately.
Oh, thank you so much. Yeah.
Really, please. Closing words. Please join. There is a data-oriented programming channel on Clojurian Slack. Please join and ask questions, contribute your ideas. Number 2, I'm really looking forward for contribution on the wiki definition concepts. And Alex, if you're able to find a better example instead of the atom, preferably one that is not in Clojure, it would be great. And if you want to take a look at the book and tell me what you think, and I'd be really happy to have a discussion, a brainstorm, get ideas, and let me know how it goes when you discuss with non-Clojure developers. If you are able to, not to convince them, but let's say to trigger their curiosity about what we like in Clojure. So thank you, Daniel, for having me in the meetup.
Yeah, absolutely. I think it was exciting having you on, because I think you and I are of a similar mind that you know, there's a lot to be gained by respecting the pragmatic concerns of Java developers and of other developers that are in well-established camps. And I really think that you know, as we make an effort, and you know, of course, you're writing a book and everything, as we kind of cross that border, like, we're both enriched, both camps have something to learn from each other, and it's exciting to be able to talk about data-oriented programming as a way of, you know, bringing some of the joy that we get from Clojure back to our world of Java or of another language that sometimes it feels like a little frustrating, but the idea that it doesn't need to be sequestered, or like, it doesn't need to take ideas from another place, is pretty refreshing. So I appreciate your enthusiasm and the sharing that you've committed to with this project, and look forward to the book.
Thank you.
And thanks everyone for joining in. This has been our April meeting of the Clojure Mid-Cities Meetup. That's the Mid-Cities area in North Texas, specifically Dallas, Southlake, Fort Worth. Look forward to seeing you guys all again at a future meetup. We've been a little bit irregular about our schedule lately. This is actually our first meetup this year, but we're hoping to have some more calendar events floating your way soon. So if you want to speak, reach out to me. And if you know someone that you'd like me to ask to speak, I'd also be happy to talk about that. And thank you, everyone. Especially thank you to our speaker.
Thank you.
Thank you, guys.
And everyone go out and contribute to the wiki.
Yeah. Alex and Simon, do you mind sending me a message on Slack so that we can, or on Twitter, so that we are in touch? Because I will never find you.
Oh, sure.
I'll
Like,
reach out to you.
what's your Twitter channel, Twitter address?
Yeah, you'll find me in the with one of the links that I shared. It will be easy for you.
Okay. Okay. Yeah. Yeah.
Please reach out. Thank you.
Sure.
Bye-bye.
Thank you.
Okay,
Bye.
fantastic. Thank you, everyone.
Thank you,
Thanks
guys.
so much.
Thank you.
Bye.